At Yak Brewing Company, we have been pioneering sustainability leadership in our sector from the very beginning. As a brewery, we are aware that our business is connected to the natural environment as it heavily relies on agricultural crops and water as our key ingredients. We rely on raw materials for our packaging, and we depend on energy and fuel to brew, transport, and refrigerate our beer. We know that brewing involves various processes which generate a significant amount of waste due to the materials involved, such as grains and water, throughout the entire value chain. Sustainability is one of our core values. Our waste management approach revolves around addressing solid waste, liquid waste, and gaseous waste separately and promoting a circular economy. In this video, we will show you how we are managing waste at the Yak Brewing Company. To reduce solid waste and byproducts, we utilize circular economy methodologies which entail repurposing, reusing, and recycling materials throughout our value chain. We supply all of the brewing ingredients and products in bulk to avoid packaging waste. To promote reuse, 80% of used beer bottles are collected and reused right here in our brewery. We take recycling seriously by sending all our excess waste materials, that includes cardboard, glass, wood, plastic strapping, paper, shrink wrap, and metals, to recycling companies. To minimize environmental impact and promote sustainability, we repurpose various wastes generated from brewing ingredients such as malt, hops, and yeast in various ways. Spent grain refers to leftover malted barley from the brewing process, and it serves as a nutritious byproduct for livestock. They contain a high amount of protein, fiber, and essential nutrients, providing a good energy source for animals. All the spent grain from our brewing process is sent to local farmers, which is utilized as supplemental feeds to their cattle. Hops are one of the essential ingredients for making beer. During the dry hopping process, a substantial amount of hops waste is generated, which we separate using a hop strainer before proceeding to the filtration stage. Our practice involves composting the hops waste to create green fertilizer, which we then utilize in our brewery's garden. This approach effectively reduces the waste directed to landfills and promotes a more sustainable relationship with the environment. Yeast is a single-celled organism used in brewing to convert sugars from grains to alcohol. Brewers' spent yeast is a byproduct of the brewing process that requires disposal after several uses in fermentations. At Yak Brewing Company, we have implemented a drying technique for spent yeast to create yeast dry cake. This byproduct is rich in vitamin B, proteins, and minerals, and we supply it to the local farmers to use as a nutritional supplement for livestock feed. We use beer membrane filtration to filter our beer instead of Kesselberg. This results in a 50% reduction in our solid waste stream at a significantly low level of energy consumption. Our beer membrane filtration system eliminates the need for harmful disposal of filter media waste. Unlike Kesselberg, which is single-use, our membrane filtration is reusable and has a lifespan of several years, which results in a lower carbon footprint. On top of that, we treat all our brewing process wastewater. We've installed a two-step anaerobic and aerobic digester that treats and purifies all of wastewater produced from the brewing process into clean water and biogas. We use the BioPack IC reactor developed by PAC, which is an anaerobic effluent treatment system that operates without oxygen. It is the first wastewater treatment system used in Nepal and is highly efficient in treating brewery wastewater. This bioreactor is divided into 4 sections. Number 1, mixing section, where the wastewater is evenly distributed into the reactor. Number 2, expanded sludge bed, where most part of the organic pollution is converted into biogas. Number 3, polishing section, where the rest of the organic pollution is treated. Number 4, gas-liquid separator, where biogas and water are separated. The brewery's wastewater is pumped into the mixing section. The water flows towards expanded sludge bed, where it is mixed with granular anaerobic biomass. The biomass consists of different types of microorganisms that work together to remove contaminating compounds from the wastewater and convert organic compounds contributing to the chemical oxygen demand into biogas. Biogas consists mainly of methane and some carbon dioxide, which is collected in the lower separation module, generating a gas lift. This causes the gas along with water to rise upwards at the top of the reactor. In the gas-liquid separator, the water and biogas are separated. Water returns back into the mixing section at the bottom of the reactor and mixes with the wastewater. This flow of water from the bottom to the top and back into the mixing section is called internal circulation. The wastewater then flows towards the polishing section. Here, the rest of the organic compound is converted into biogas. This biogas is collected in the upper separation module and flows towards the gas-liquid separator. The biogas leaves the reactor at the top, and the treated wastewater leaves the reactor through the effluent pipe. The resulting methane gas is then collected and reused as fuel for our boilers, which reduces the primary requirement for non-fossil fuel by 15%. COD refers to the amount of oxygen required to chemically oxidize and degrade organic and inorganic matter in wastewater. It is an indicator of the oxidizable pollutants present in wastewater and the effectiveness of wastewater treatment processes. By anaerobic treatment, we are able to achieve a 75 to 80% reduction of chemical oxygen demand in wastewater. Brewery wastewater contains a high biological oxygen demand, also known as BOD, due to presence of organic components such as sugar, soluble starch, ethanol, and volatile fatty acids obtained from the brewing process. To address this, we further purify the partially treated wastewater from anaerobic digester to aerobic treatment plant. Our aerobic treatment plant is equipped with large aeration tanks where the oxygen is introduced into wastewater. The oxygen supports the growth and activity of aerobic bacteria and other microorganisms. During the aerobic treatment process, the microorganisms break down organic matters into carbon dioxide, water, and microbial biomass. This process also removes nitrogen and phosphorus from the wastewater. The treated water has become cleaner, which is monitored by its reduced BOD levels. BOD refers to the amount of oxygen required by bacteria and other microorganisms to decompose organic matter present in the wastewater through the aerobic treatment process. Upon achieving a reduction in BOD levels, which indicates a more effective aerobic treatment process, we collect the treated water in the settling tanks for reuse. During anaerobic and aerobic treatment, a highly equipped clarifier mechanism is used to separate suspended solids and other impurities, such as oil and grease residues, from the wastewater. This mechanism consists of a large, circular tank designed to allow particles to settle under the influence of gravity. The clarified effluent is then collected and further treated or discharged. The primary clarifier removes 60% of suspended solids and 30 to 40% of BOD. In this process, sludge settles at the bottom of each clarifier basin and it is collected by a rake before being removed through a sludge removal system.
The collected sludge is stored in sludge storage tanks. Centrifugation is used for the thickening and dewatering of sludge. This process results in dewatered sludge with a high concentration of dry solids, also known as DS.
At Yak Brewing Company, our effluent treatment plant, ETP, has two separate high-motion centrifuge systems called decanters, which are installed to dry out the sludge collected in the sludge tank. Depending upon the nature of solids, dry sludge can be repurposed as fertilizer or any landfill purposes.
Overall, our combined anaerobic and aerobic treatment plant in the brewery efficiently treats wastewater into clean water, ensuring the sustainable management of wastewater from our brewery operations. By implementing proper wastewater treatment methods, we minimize several negative impacts on water quality, aquatic ecosystems, public health risks, and environmental damage. On-site, we can treat 500 cubic meters of wastewater every day to reduce the environmental impact while producing green energy. Carbon dioxide is a major byproduct of the brewing process generated during fermentation, and it can be captured for reuse within the brewing system. We have installed a carbon dioxide recovery plant with a capacity of 150 kilograms per hour in our brewery to collect the carbon dioxide produced during fermentation. This captured carbon dioxide is purified, compressed, and then reused for carbonating beer during the bottling process. Our carbon dioxide recovery system offsets 182 tons of carbon emissions each year. Through the reuse of a byproduct that would otherwise be released into the atmosphere, we aim to minimize carbon footprint and promote sustainability in our brewing process. If you're eager to witness our sustainability practices in action, we invite you to visit our brewery located in Kurintar, Chitwan. Cheers!